So the first time I recorded this video, I had shared my Zoom screen to the wrong screen, and so you didn't actually see any of my work. Rather than redoing the whole problem, I'm going to talk through the solution. I will still provide a link to the audio if you would like to look at that as you review the notes individually. So to get started, we looked at this system of equations. We wrote a matrix, the variable matrix, which is x, y, z, and then the solution matrix, 9, -4, 17. Of particular note, because our second equation does not have a z variable, the coefficient of z is understood to be 0. For our first step, I noticed that even though the first row has two ones, because the second row has a -1 and a 0, this 0 is going to minimize the number of individual computations we have to make. So I made our second row the pivot, the part that stays unchanged from one line to the next. And then I added row 1 and row 2 to cancel out the first component in the first row, and then row 3 plus 2 times row 2 to cancel out the first component. If you watch the video, you'll hear in the audio that I said I was going to use the first row to cancel out the ones in the middle column, or to cancel out the 3 and 1 in the middle column. And then I realized I had made a dire mistake, because if I use the first row to cancel out the middle terms, then I would be changing a 0 back into a number. And I don't want to change zeros into numbers if the zeros are in a place where I want them to stay. So instead, I changed direction. I multiplied the second row by -1 so that I could get a +1 in the first coordinate. And then I used the first row to get rid of the 1 in the middle of the third row. So that's row 3 minus row 1. In the next step, I noticed that I had in the third row 0, 0, 4. In order to make this a 1, I multiplied the whole row by 1/4. Again, we can't divide a row by a number, but we can distribute the multiplication into each of our terms in the row. Then noticing that I want this leading 1 to be in this spot up here, I switched row 1 and row 2 before moving on to the next step. You'll notice this part in teal says from the next line, so we're going to ignore it for the moment, and then I'll talk more about that in a second. So as you can see, we switched our first and second row so that we were able to get this staircase pattern. So doop, 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 doop. That is what we want from reduced row echelon form. And then, now that I have a 1 in the third component of the third row, I was able to use row 2 minus row 3 to get rid of the 1 that's now in the third component of our second row. It did take some fraction algebra to combine like terms, but those are skills that we've practiced. We might not love them because there's more numbers to keep track of, but it does still work and get us to where we need to go. After I wrote this line in brown, I realized that I still had to get rid of this -3, but because this first row hadn't changed from one matrix to the next, I decided rather than writing the whole matrix 2 more times, I would just calculate row 1 plus 3 row 2 using the row 2 that's in brown on this last matrix that I've labeled as the pivot. So then that is where our +3 plus 15 over 4 plus 9 over 4 and plus 9. Yes, that was also 9 over 4. This small character sometimes gets a little hard to read. I should have noticed that and fixed it sooner. In any case, or excuse me, 3/4, because I'm really multiplying this row by 3. No, it's not that row. I am multiplying this one by 3, and it's negative 1/4, so negative 3/4 up there, which you can see written more clearly down here. So we did a lot more adding and subtracting fractions. And then this part of our matrix, now that we have gotten the left-hand side to the identity in reduced row echelon form, our matrix over here is A inverse, which writing in highlighter doesn't look all that convincingly precise. So then we moved A inverse down. This is our solution matrix, 9, negative 4, 17 from the beginning. I then multiplied pairwise, just like we normally do, to get our 3 terms. I added them using my calculator. 64 divided by 4 is 16. We repeated this process for the row in brown and the third row in green. Note that that's a negative 1/4 right here. And then we were able to find our solution, x equals 16, y equals 4, and z equal to 1. I also made the comment that even though this took a long time, the reality is no matter how big or small the matrix is, it doesn't necessarily make the problem more difficult. You might have more computations to do, which might make it more work, but it's not necessarily more challenging work. As long as you go slow and keep track of your numbers carefully, you'll do fine. I also related the story of why I use colors to help keep track of things as I'm working through a problem. So all the way back in my college calculus class, which was my second semester in college, my teacher included a requirement on the syllabus that we needed colored pencils for the class. I didn't really understand the reasoning at first, but as we got through the semester doing more and more complicated problems, where although we weren't working with matrices, there were some problems that had as many distinct parts. Using a colored pencil was significantly easier to keep track of things. It helped make my work look more organized. And with more organized work, I was able to think more clearly without having to worry about misplacing a term, adding or subtracting incorrectly. And so I strongly encourage you to get some color pencils. I also really like these colored pens. If you can see in the thumbnail, I have lots of different color pens. Mainly, I use the pens because if I scan notes for students, pencil doesn't show up as nicely. But even when I'm working on a digital medium like Smart Notebook, using multiple colors helps keeps things organized, and that helps take some of the pressure off of maintaining a detailed awareness of where everything is, because the colors help us visually organize things. And so again, just to reiterate a point from before, even though this had a lot of little steps, all of those steps really come down to multiplying and adding and subtracting numbers. And those are skills that we've all developed and practiced our entire lives. So try not to be intimidated. Take it one step at a time. If you start to feel unsure, pause for a moment and say, I'm going to do one thing focus on that, then move to the next step. That's why, for example, up in this first step, I made the note in red, and then I wrote down the row in red, and then I came back to do the part in green. Using multiple colors can also help us organize that more visually, so we can focus on just one step at a time. And with that, our unit on matrix algebra, linear algebra, comes to a close. It really is a fascinating field in mathematics, and I hope you will consider, if you have the opportunity to take a linear algebra class in college, that you do, especially if you are going into any fields of engineering. Linear algebra is a really valuable course to take.